What's up? Welcome back to a new video. Today I want to build with you a high voltage capacitor for my Tesla coil. Now I showed there in the last video, you can see it. And that's really DIY. So in this case I want to use these foils. I don't know how this is called on English. Clear side foils or overhead projector foils. So these are polyethylene foils. So in this case they have a voltage rating of about 40,000 volts or 40 kilovolts at 1 millimeter thickness. These foils are actually 0.15 millimeters thick. So when they two layers of them, so that's double layered. So in this case I should be safe with over 4 kilovolts of voltage rating before this breaks through, to build a high voltage capacitor for my voltage doubler circuit. So in this case this thing I think will end up being really big. So I bought some aluminium foil. Want to, not like this, a little bit more beautiful. Want to cut this like this, stick it into the projector foil, and then I layer them up like sandwich layers, and so on until my goal is to get about 1 or maybe 2 microfarad. That's depending on how big this voltage rating actually is of this foil. First I want to test it with you. I want to show it you. I built just a little capacitor with this foil. First I using the double layer, and then I want to use just one layer, but I think that's not enough. I think this voltage will break through and destroy this capacitor. But I just have to find this out to make sure, or maybe a little bit more sure, that this will be much work. So I ordered many of these foils to build this capacitor, so to make sure that this capacitor not dies instantly on the harsh high voltage peaks these can exist in this Tesla coil applications. So I want to say let's start. So the first thing I want to do is stick the aluminum foil in these plastic decks and stack them like that. So now we have between the aluminum foils 2 layers of this polyethylene plastic foil. So in this case I want to measure first the capacity of this capacitor. So I hook up my that's not easy with just one hand, my multimeter, and we have already with just this layer 1.5 nanofarad or 3 when I push it down. We don't even have here the edges. So I think we're getting with this one layer up to about 3.5 nanofarad. So that's that's really good. So, and the next what I want to test is just put one foil into the back and layering another foil over it. So in this case we have just one layer of this polyethylene foil between these aluminum foils, In this case, I think this voltage rating will be not enough, but when this stone breaks through, I want to test it now later on my Tesla coil. When this doesn't break through, I think I will use it like this, because I don't need so many of these clear side foils. Yeah, so I can build a capacitor with a higher capacity that has the same size of the like the other application. So we have already a little bit more capacity, because the foils laying more near together. The distance between these foils is not that big. So yeah, when I push it down, we have already 3.5 nanofarad. That's nice. So yeah, let's test it and let's. So now I hooked this up, this capacitor, to my voltage doubler circuit. And now first we working with 2 layers of this polyethylene between the aluminum foil. So in this case, this should be alright with the voltage rating and don't break through. But yeah, let's test it. I made it dark. Just switch it on. By the way, I worked a little bit on my coil. This roll hangs already 90 centimeters over the breakout point. Sometimes it's getting rigid. But yeah. Now I removed one foil, you see it there. So now we have between these aluminum foils just one single layer of this polyethylene foil. And yeah, let's see if it dies. Oh, this works too. Okay, in this case, I have to say, I'm not really sure. I think I will go up with the power on the Tesla coil to push it really hard to get the high voltage peaks, because I'm a little bit nervous about that, just using one layer. Now I switched my ballast transformer to almost maximum power. So that's I think 190 volts input now. Yeah. And again, forgot to plug it in. Yeah, my safety rules getting me there every time. But yeah, that's good. Better than get shocked. So test it. I have to say, this looks fine. No problem. So, we have much work. Yeah, I got the aluminum foil. These are together about 40 meters of nice smooth foil. So, and we got about 200 of these clear side foils. yeah. So, and I think about it a little bit. So we tested the capacitor before on my Tesla coil, and just with one layer it worked just fine. But I'm a little bit nervous about some production fails. So, I mean, when these foils have some failing in the production, or it's just slightly damaged somewhere at just one layer, the capacitor will instantly destroy itself. So in this case, that's bad, because I can have the double of the capacity with this foils when I just use one layer, or more than the double. But I'm a little bit nervous about that. That's the reason that I would say I use double layered. So I think it's a little bit safer. So it's safer at high voltage peaks, and safer in the case if any little fail or a little hole or whatever is in this foil. So yeah, it's not that nice, but yeah, I do it like that. I think it's better. So the second thing I figured out after I deinstalled this capacitor, and I had another foils laying around here with aluminum foil sticked in there, and I was getting them together and I got shocked. Some static charge was built up, I think, because I running the Tesla coil for tests or whatever. So in this reason I have to be really careful with this, because this capacitor later will store about 1 or 2 microfarad of capacity, and this up to, I don't know, 10,000, maybe 20,000 volts. So that's no joke, really. And I will say, because all in all we work with really high voltages here, I want to say be careful with stuff like that. This can end deadly and really serious. So yeah, I don't recommend to do this, and when you do it and something happens, I'm not responsible for any. So in this case, I just want to say it because that's really sketchy stuff we work here with. So especially this DIY stuff and this cables flying around everywhere. So yeah, be careful and stay safe. That's what I want to say. So let's build this thing. I was thinking about how I solve my problem, how I cut this foil, how I get this in these clear side foils, and yeah, I made some of them and I figured out that's the hell. It's really not easy to do this. Shit. So yeah, first thing, pull this foil. And when I bought this foil, this was really cheap foil out of some super sale market, and this foil is so extremely thin. This is crazy. So then I lay this over it with a cutting knife. Cut this. That's crazy. I think to build this capacitor, this really will take a while, for sure. Because I have to be really careful, don't rip this foil, or I have to get it really nice and flat, like this. Yeah, and I have to do this for now 196 times more. So I stopped the time a little bit, and now I know I need about 6.5 minutes for 5 of these things. So in this case, I know I will need about 4 hours for this capacitor, or just to get the aluminum foil into these clear side foils. Yeah, I don't want to film this, so we'll see you later. Bye. Finally, yeah, packed 100 of these foils with the aluminum foil. Yeah, that's a stack. Used about, yeah, a little over 20 meters of aluminum foil, and yeah. So now I will compress this a little bit with this wooden board, and yeah, we measure the capacity, because it's not even the half of what I have left. So because I have still 3 packs, each 50 pieces of them. Yeah, that will be a lot of work today. Okay, let's measure it. I compressed this, yeah, with some mods. So let's measure it. Oh, that's almost a half microfarad. That's nice, and it's not even really heavy compressed, so in this case there is some air, still some air between, so I have to compress this down really strong. So later, when I finish this capacitor, I have to clamp this with some really thick wood and screw it together to compress it really hard, to get rid of the air, and yeah, this will make a difference. So the capacity will rise a little bit with that. So I think when I finish this thing, that will have around 1 microfarad, and yeah, this will be really awesome. Yeah, let's continue with that. So now, finished it. Oh, what the heck. My brain is completely wasted. I have to say, I'm done. So these are about 230 sheets of aluminum foil and 230 sheets of these clear side foils. So pack this together. I didn't measure it now because I can't quite get a good contact. So first I have to compress this, and I have to think about how I will compress this. I think I will use some acrylic glass, cut out some two pieces, put them on top, and then I cut out some of the really thick wood, and then I screw it together and compress this down. And yeah, then I have to figure out how I cut this aluminum foil to build connections. So yeah, I think, or I will do this now, and then we come back and measure this beast or pile of sheets, whatever. We have the finished capacitor. Yep. I cut all these aluminum foil sheets here and drilled them up, screwed them on there. Yeah, pressed everything down with really thick wooden planks. Between them I have acrylic glass. Oh yeah, here you can see all the layers. That's crazy. So yeah, in this case now we can measure the capacity of this monster. Let's see. No. How it rises. Whoop. 1.16 microfarad. That's that's quite a lot for a capacitor. That's I think it's capable of 5-6 kilovolts safely. I don't know how much I can give this thing, probably up to 10 kilovolts, but I think that's a little risky. But yeah, I already calculated this, and at 10 kilovolts this capacitor has over 50 joules in energy in it. And yeah, okay, yeah, I would say let's test this, and I hang up a microwave oven transformer and let's see if it runs or if it dies. Hopefully not. This was a lot of work. So now yeah, all in all, these are, I think, 8 or 9 hours of work now. That's crazy. Yeah, but we didn't build this to sit somewhere on the bench, so it have to work. Let's test. I built a test circuit. In this case, that's just a microwave oven transformer with a diode for this. Builds up with the capacitor, builds a voltage doubler. So yeah, I would say first I show you how the arcs are normally from the microwave oven transformer. Then I show you the arcs over the voltage doubler, and then I switch the system off and I discharge the capacitor. So that's quite interesting. Okay, let's start this. Just switch it on. So here we have first the typical arcs from a microwave oven transformer. Then we have the arcs from the voltage doubler and some interesting phenomenon. This cat is really loud. That's crazy. This capacitor, I think, because it's so big, builds up an electromagnetic field, and this is alternating, and this whole capacitor will shake. That's really crazy. So now I switch this off, but the capacitor is still charged. So now I discharge the capacitor, and yeah, you will see what power is behind this thing. Yeah, it's loud. Yeah, that's it. Now, like I said before, I want to use this capacitor or test this capacitor on my Tesla coil. If this makes any changes at the breakout or on the arcs of the Tesla coil. I mean, it's just 1 microfarad. It can be that not really much is changing, but yeah, anyway, let's test this. So this capacitor is not hooked up. I want to test this first without this capacitor, and I'm on the lowest setting on my ballast transformer, so we work with less power. So let's start this. Okay, the arcs are sometimes reaching the 90 centimeters. So this tape roll here hangs about 90 centimeters high, but it's more likely slightly under these 90 centimeters. Sometimes a peak will reach this, but not very often. Okay, now hook up this capacitor. Let's test this. I would say when there is a slight change, it's really slightly, so don't know when I'm honest. I mean, it's just 1 microfarad in this case, so okay. I think I have to do this experiment a little bit different. So now I unhooked the biggest part of my capacitor bank. Now I only have these capacitors that I have internally there. These are about 2 microfarads. So with only them I have a really little output. Okay, yeah, but it's not near that big than before. So, and now I want to hook on my DY capacitor, and we'll see if there is any difference between. So now I hooked on the DY capacitor instead of the big capacitor bank. So let's see if this makes any difference on the output. Oh, got a little bit scared. Yeah, there are some differences. So this, oh yeah, for sure. We're almost back to the 90s. Well, yeah, more like 80 centimeters. Okay, this tells me so that the difference of 1 microfarad is just too small to see it, or to really can see it, because I already have so much capacity on the voltage doubler circuit. Yeah, okay, so this works. Yeah, unlucky that I'm not able to unhook this, or I'm able to unhook the other capacitors. I would like to run it just only on this DY capacitor, but that's a lot of work. There's many cables that I have to change, so in this case I can show you that. But yeah, you see now this capacitor works. Yeah, kind of works. I mean, 1 microfarad is now in this scenario not really much, so this capacitor is able to do much more, but not at these voltages. So yeah, but I like this experiment a lot. It's really cool, but take a lot of time, I have to say. Yeah, when you also like this video, like and subscribe, and also in the future, or in the near future, I want to build another capacitor and try to experiment with that, and that's the primary capacitor. And I think that's a lot easier than to build such a monster, because here I only need around 1 to 1.2 nanofarads, and I'm ending up with a lot smaller capacitor, and yeah, it's just much more simple. And I wonder how this works in a primary circuit. So in this case I don't want to use the plastic sheets, the overhead foils. So in this case I want to work with glass sheets and aluminum plates. Maybe make this capacitor yeah, that I can vary the capacitance. That would be really nice. But yeah, that's something for the future. When you want to see this, yeah, subscribe and we see us in the future. So that's from me today. Have a nice evening, have a nice day. Bye bye.